Hi everybody, today we're going to be looking at finding the volume and surface area of a sphere. You might want to pause here to grab yourself a pen and paper to take any notes, and then we'll get started. So like I've said, we'll be going to be looking at solving problems involving the surface area and volume of spheres, then we'll be looking at some multi-part problems, then we'll be looking at an algebraic version. So in order to calculate the surface area and volume of a sphere, we need the following formulae. So the surface area is 4 pi r squared and the volume is 4/3 pi r cubed. And the radius goes from the centre of the sphere to the edge. In this first example, we're asked to find the volume of a sphere with a radius of 3.2 metres. So the volume formula is 4/3 pi r cubed. So that's the formula I'm going to use. So now I'm going to substitute in my radius of 3.2. So 4/3 times pi times 3.2 cubed. Pop that in my calculator exactly as it is, and that'll give me the volume of that sphere. So I've popped it in my calculator and I've got 137.2582774, which when I round that to one decimal place, it gives me 137.3 metres cubed. So I've just substituted in my radius of 3.2 for this question. So my next question asks us to find the surface area of a sphere this time. So this is the formula we're going to be interested in. The difference in this question is that it gives us the diameter of 6.5. And if we look at the picture, that's all the way across the sphere. And what we want is just from the centre to the edge. So that's half of the diameter. So in order to find the radius, we're just going to half the 6.5. So our radius is 3.25. So now, to calculate the surface area, we're going to use our surface area formula, 4 pi r squared. And where I see an r, I'm going to swap it for my radius. 4 times pi times 3.25 squared. Pop that in my calculator, and I get 137.732289 centimetres squared, which when I round that to one decimal place, I get 137.7 centimetres squared. And don't forget to keep your units. So now we've looked at finding the volume and surface area of a sphere. Now we're going to look at finding the volume and surface area of a hemisphere, which is half a sphere. So the first thing we're going to look at is volume, and then we'll come back to surface area afterwards. So the volume of this sphere, if we imagine the whole sphere was here, we'd use 4/3 pi r cubed. So to begin with, we're going to do that. We're going to do the volume of the sphere, which is 4/3 pi r cubed. And like we've done before, we're going to swap this r cubed to 2.1 centimetres. So 4/3 times pi times 2.1 cubed. Pop that in your calculator and you get 38.7923860 centimetres cubed. That's the volume of the full sphere. We want the volume of half the sphere, the hemisphere, so we're going to divide that by 2. When we've divided that by 2, we get the answer of 19.4 centimetres cubed. So the volume of our hemisphere is 19.4 centimetres cubed. So now we're going to look at the surface area of the hemisphere. So if we imagine the full sphere is there and we calculated the surface area, we do 4 pi r squared, which is what we're going to do. And we're going to do 4 times pi times 2.1 squared. Pop that in your calculator and you get 55.417694441. And I haven't rounded it because I haven't finished the question yet. So I've left it in my calculator. So that's the surface area of the sphere, of the full sphere. And the curved surface area of the hemisphere is therefore going to be half of that. So it's going to be that divided by 2. Which is 27.7088472. If we look now, that gives us the curved surface area. It doesn't give us the surface area of the base, and we need that as well to get the total surface area. So the base is a circle. So we're going to work out the area of the circle, which is pi times r squared, pi r squared. So my radius is 2.1, pi times 2.1 squared. So the area of the circle is 13.85442236 centimetres squared. And then the total surface area is going to be this area of the circle added to the area of the hemisphere. So 13.85442236 added to 27.70888472, which when you add them together and round to one decimal place gives you 41.6 centimetres squared. We've now got a multi-part question here. So we've got a tube of tennis balls is a cylinder with a radius of 3.8 centimetres. It contains 3 balls which fit exactly inside it. First part of the question is how high is the tube? And then part B, what is the volume of the empty space within the tube? So the first thing I'm going to do is draw myself a little sketch so I can visualise what's going on. So the tube of tennis balls, there's 3 inside there that fit exactly. So then we're going to look at how high the tube is. So the information that we're given here is the radius of your sphere and of your cylinder is 3.8. So if your radius of your cylinder is 3.8, the radius of your spheres are also going to be 3.8. So if I know my radius is 3.8, the diameter of my sphere will be double that, which is 7.6. So it could be 7.6 like that, or it could be 7.6 like that. So 7.6, 7.6, and 7.6 gives us the height of the cylinder. So 3 lots of 7.6 is 22.8, which is the height of the cylinder. So part B of the question asks for the volume of the empty space within the tube. So I've added in now that my height of my cylinder is 22.8 and my radius of my sphere and of my cylinder is 3.8. So now I'm going to calculate the volume of the cylinder. So the volume of the cylinder, remember it's a prism, so it's the area of the cross section times by the height. And the cross section here is a circle. So pi r squared times by the height of the cylinder. So my radius is 3.8 and the height of my cylinder is 22.8. So pi times 3.8 squared times by 22.8. So I've got the area of the circle times by the height of the cylinder to give the volume of the cylinder. Put that in my calculator and I get 1034.312833 centimetres cubed. And because I haven't finished the question, I'm not rounding that answer yet. Then I've got my 3 spheres. So the space in the cylinder will be the volume of the whole cylinder without the 3 spheres, the 3 tennis balls inside. So remember, the volume of a sphere is 4/3 pi r cubed. And how many have I got there? 1, 2, 3, and they're identical. So I'm going to do 3 lots of the volume of one sphere. So 3 lots of 4/3 times pi times 3.8 cubed. Put that in my calculator and I get 689.5418884. So now I want the volume of the empty space in the tube. So that's the volume of my cylinder in total, including the tennis balls. And then that's the volume of my 3 spheres. So I'm going to subtract that, which leaves me with 344.7709446 centimetres cubed, which to one decimal place is 344.8 centimetres cubed. Then we're now going to look at a past exam question that involves a bit of algebra, a bit of rearranging equations. So I'm just going to pause for a second here to give you an opportunity to pause the video in case you want to have a go at it first. Okay, so the question says the surface area of a sphere is 1,380 centimetres squared. Calculate the volume of the sphere, state the units in your answer. So we know that we're eventually going to have to calculate the volume of the sphere. If we look, to calculate the volume, we need the radius. Okay, so our aim now to be able to get to the volume is to calculate the radius. So if we look at our surface area here, that's got radius involved. So we're going to use this formula to help us out. So surface area is 4 pi r squared. So like we did when we were calculating surface area, we're going to swap in, we're going to substitute in what we know. So here, instead of knowing the radius, we know the surface area. So I'm swapping in for my surface area 1,380, and that's 4 pi r squared. If you think about your knowledge of algebra and rearranging equations, all of these here are linked by a multiply. So 4 times pi times r squared. So to get our 4 pi over to the other side, to rearrange, we're going to divide through by 4 pi. So we're left with 1,380 divided by 4 pi is r squared. So when I pop that in my calculator, I get 109.8169107. And I haven't rounded that because I haven't finished the question. That's the radius squared. So to find the radius, the opposite of squaring is square rooting. So I'm going to square root 109 to get 10.47935641. And again, like I didn't round that, I haven't rounded that. Okay, so that's given me my radius of my sphere. Now I'm going to use this to calculate my volume. So my volume, again, formula, 4/3 pi r cubed. Then my radius is 10.47935641. So I'm going to swap that in, substitute it in. 4/3 times pi times 10.47935641 cubed, which is 4,820.50395 centimetres cubed, which is 4,820.5 centimetres cubed to 1 decimal place. I hope this helps with the work that I've set you. If you need any support, don't forget you can get in touch. Thank you for listening.